Today's lesson is called Working with Ice, Human Activity in Glacial Landscapes. So far, we have studied how glaciers form, move, erode, transport, and deposit material. We have looked at landforms such as quarries, arêtes, U-shaped valleys, moraines, drumlins, and erratics. Today, we are moving from physical geography to human geography. We are going to ask, how do people use glacial landscapes, and what problems can this create? Glaciated areas can be beautiful, dramatic, and valuable. They provide opportunities for tourism, farming, forestry, quarrying, water storage, and hydroelectric power. But these landscapes are also fragile. Too much development can damage the very environments people come to enjoy. Let's begin with the learning objectives. By the end of this lesson, you will be able to explain how humans use glaciated regions for tourism and the economy. You will analyze the role of glaciated valleys in water and energy production. You will evaluate conflicts between conservation and development. You will also recall key depositional features from previous learning. The key skill today is evaluation. That means we are not just listing human activities. We are weighing up their benefits and problems. For example, a quarry may create jobs, but it may also damage scenery, increase traffic, and harm habitats. A strong geographer can explain both sides before reaching a judgment. Before we go further, let's define today's key vocabulary. The first word is sustainability. Sustainability means meeting the needs of people today without damaging the ability of future generations to meet their needs. For example, tourism may be sustainable if it brings money into an area while protecting the landscape for the future. The second word is conservation. Conservation means protecting plants, animals, landscapes, and natural habitats from damage caused by human activity. The third word is industry. Industry means economic activity concerned with producing goods or processing raw materials. In glaciated uplands, this might include quarrying, forestry, farming, and energy production. The fourth word is infrastructure. Infrastructure means the basic physical structures needed for society to function. This includes roads, bridges, dams, reservoirs, footpaths, car parks, power lines, and visitor centers. These four words are useful because they help us explain why conflicts happen. Development often needs infrastructure and industry. Conservation tries to protect the landscape. Sustainability asks whether we can balance both. Before we look at how humans use glacial landscapes, we need to remember what the ice left behind. Glaciers act like giant conveyor belts. They transport material as load, carrying rocks on top of the ice, inside the ice, and underneath the ice. When a glacier melts, it deposits this material. The unsorted material deposited directly by a glacier is called till, or boulder clay. Till can form landforms such as moraines and drumlins. Moraines are ridges of till. A terminal moraine marks the furthest point reached by the glacier. These landforms are important because they are part of the landscape people now use. They can influence farming, tourism, road building, conservation, and planning decisions. For example, a drumlin field might be attractive and scientifically valuable, but it could also be threatened by quarrying or development. So today we are not just asking how ice shaped the land. We are asking how people now use that land. Let's ask a question. Why might glacial landforms be worth protecting? Here's a model answer. Because they provide evidence of past ice movement and climate change, they may support habitats, and they can attract tourism. Let's begin with a quick progress check. Question 1. What is the name for the unsorted material deposited directly by a melting glacier? Question 2. Which landform is an elongated, teardrop-shaped hill of glacial till? Question 3. Where is a lateral moraine found in relation to a glacier? Write down your answers now. Try to answer from memory. These are key terms from our previous lesson on transportation and deposition. Let's check the answers. Question 1. The unsorted material deposited by a glacier is called till or boulder clay. Question 2. An elongated, teardrop-shaped hill of glacial till is a drumlin. Question 3. A lateral moraine is found along the sides of a glacier valley. Well done. These features matter today because human activity often takes place on or around these glacial landscapes. Now let's think about the hook question. Imagine a landscape that is too steep for cities, too cold for most crops, and too rugged for easy travel. At first, That might sound like a landscape with very little value. But glaciated areas such as the Lake District, the Scottish Highlands, Snowdonia, and the Alps have become some of the most valuable landscapes on Earth. Why? Because their physical geography creates opportunities. Steep slopes and dramatic scenery attract tourists. High rainfall and deep valleys make them useful for reservoirs and hydroelectric power. Hard rocks can be quarried for building materials. Thin soils may not support crops, but they can support sheep farming. Poor soils and high rainfall can also be suitable for forestry. So, although glaciated landscapes can be difficult places to live and work, they offer many valuable resources. Let's begin with tourism and recreation. Glaciated landscapes often have dramatic topography. They include mountains, steep slopes, lakes, waterfalls, ridges, valleys, and exposed rock. This attracts millions of visitors. Common activities include hiking, mountain biking, skiing, rock climbing, sightseeing, camping, and water sports. Tourism can bring many benefits. It supports local hotels, cafes, restaurants, shops, campsites, outdoor activity companies, and transport services. It can create jobs and help keep rural communities alive. However, tourism can also create problems. Popular locations can become honeypots. A honeypot site is a place that attracts very large numbers of visitors. This can cause congestion, pressure on car parks, noise, litter, and overcrowding. Footpaths can become eroded when thousands of people walk the same routes. Wildlife may be disturbed. House prices can rise if second homes and holiday lets become common. So tourism is not automatically good or bad. It depends on how it is managed. Let's ask a question. What is one benefit and one problem of tourism in glaciated areas? Here's a model answer. One benefit is that tourism creates jobs and income for local businesses. One problem is that it can cause footpath erosion, congestion, litter, and pressure on habitats. Now let's look at other economic activities. The first is quarrying. Upland glaciated areas often contain hard rocks such as slate, granite, and limestone. These rocks can be valuable for building materials, roofing, roadstone, and construction. Quarrying creates jobs and provides materials needed by society. However, it can also damage the landscape. It creates noise, dust, scars on hillsides, increased lorry traffic, and habitat loss. The second activity is farming. Farming in glaciated uplands is often limited. The slopes are steep, the climate is cooler and wetter, and soils are often thin and poor. This means crop farming is difficult. Instead, many upland areas are used for sheep grazing. Sheep can survive on rough pasture and steep slopes better than many other livestock. However, overgrazing can cause soil erosion, reduce vegetation, and damage habitats. The third activity is forestry. Coniferous trees are often planted in upland valleys because they can grow in poorer soils and wet conditions. Forestry provides timber and jobs, and trees can also help absorb carbon dioxide. However, large plantations of the same tree species can reduce biodiversity. They may also change soil conditions and affect water quality. So again, there is a balance. These industries provide resources and employment, but they can also damage fragile environments. Let's ask a question. Why is sheep farming more common than crop farming in many upland glaciated areas? Here's a model question. Because steep slopes, thin soils, and cool wet conditions make crop farming difficult, while sheep can graze on rough upland pasture. Now let's look at one of the most important uses of glaciated valleys, water storage and energy production. The slide calls water the white oil. This means water is an extremely valuable resource. Glaciated landscapes are ideal for reservoirs and HEP, which stands for hydroelectric power. There are several reasons for this. First, glaciated valleys often have steep sides and deep troughs. This makes them good locations for dams because a dam can hold back a large amount of water. Second, upland glaciated areas often receive high rainfall. This provides a steady supply of water to fill reservoirs. Third, many glacial troughs have narrow outlets. This can make dam construction cheaper and more efficient. Reservoirs provide drinking water for cities, water for farming and industry, and sometimes recreation. Hydroelectric power uses the movement of water to generate electricity. Water stored high up behind a dam has potential energy. When it is released downhill through pipes, that energy is converted into movement, which turns turbines and generates electricity. HEP is renewable and does not directly produce greenhouse gases during operation. However, reservoirs and dams can flood valleys, damage habitats, change river flow, and affect local communities. Let's ask a question. Why are glaciated valleys good locations for reservoirs? Here's a model answer. Because they are deep, steep-sided valleys with high rainfall and narrow outlets, making them easier to dam and useful for storing large amounts of water. Now let's order the process of generating energy from a glaciated valley reservoir. The 4 steps are: water flows down through high-pressure pipes called penstocks. The turbine drives a generator to produce electricity. Water is trapped behind a dam in a deep glacial trough. The force of the moving water turns a turbine. Put these in the correct order. Think about what must happen first. Before water can flow downhill, it needs to be stored behind the dam. The correct order is: first, water is trapped behind a dam in a deep glacial trough. Second, water flows down through high-pressure pipes called penstocks. Third, the force of the moving water turns a turbine. Fourth, the turbine drives a generator to produce electricity. This is the basic process of hydroelectric power. A strong exam answer should link the physical landscape to the energy process. For example, glaciated valleys are suitable for HEP because their steep sides and high rainfall allow water to be stored at height and released through penstocks to turn turbines. Now we come to one of the most important themes in today's lesson: conservation versus development. Many glaciated landscapes are protected as national parks or conservation areas because of their beauty, habitats, geology, and cultural value. But these are also living, working landscapes. People need jobs, homes, roads, water, energy, and income. This creates conflict. For example, should a wind farm be built on a pristine ridge if it produces renewable energy but affects the view? Should a quarry be expanded if it creates jobs but scars the landscape and increases lorry traffic? Should a reservoir be built if it supplies water to a city but floods a valley? The slide gives the example of Thirlmere in the Lake District. Thirlmere was dammed in the 19th century to provide water for Manchester. This sparked one of the first major conservation battles in the UK because people objected to the impact on the natural landscape. This kind of conflict still happens today. The challenge is to manage glaciated landscapes sustainably. That means allowing people to benefit from the landscape without destroying the features, habitats, and beauty that make it valuable in the first place. Let's ask a question. Why might conservationists oppose development in a national park? Here's a model answer. Because development can damage scenery, habitats, wildlife, geological features, and the peaceful character of the landscape. Now let's test our evaluation skills. The statement is: building a tourist zip wire across a glacial valley is always a bad idea for the environment. Thumbs up if you think this is true. Thumbs down if you think this is false. The key word is always. In geography, words like always and never are often risky because the answer usually depends on the situation. The correct answer is false. Building a tourist zip wire across a glacial valley is not always a bad idea. It may have negative impacts. For example, it could create visual pollution, noise, traffic, and disturbance to wildlife. Some people may feel it spoils the natural beauty of the landscape. However, it could also provide benefits. It may create local jobs, support tourism businesses, and provide income that can help fund conservation work. Compared with some other developments, a zip wire may have a relatively limited physical footprint if it is carefully planned and managed. So the strongest answer is balanced. We should not simply say, development is bad, or tourism is good. Instead, we should ask, how much damage will it cause? Who benefits? Can the impacts be managed? Is it sustainable in the long term? The best explanation is option B. It can provide sustainable income for locals and fund conservation, though it creates visual pollution. This is a good example of evaluation. A development may have both positive and negative impacts. The role of a geographer is to weigh these up before making a judgment. Now we are going to hold a short class debate. A company wants to open a new superquarry in a national park. It will create 200 jobs, but it will increase lorry traffic and destroy a unique drumlin field. Should the government approve it? Let's think about arguments for and against. Arguments for approving the quarry. It creates jobs for local people. It provides building materials that society needs. It may bring money into the local economy. It may increase council tax or business revenue. It could reduce the need to import materials from elsewhere. Arguments against approving the quarry. It damages a protected landscape. It destroys a unique drumlin field, which is evidence of past glaciation. It may reduce tourism because visitors come for scenery and tranquility. It increases noise, dust, air pollution, and lorry traffic. Once the rock is removed, it cannot truly be replaced. Now I want you to decide your position. Should it be approved, rejected, or approved only with strict conditions? You might have said the quarry should be approved because it creates local jobs, provides useful materials, and supports the local economy. You might have said it should be rejected because it damages tourism, destroys glacial heritage, and causes noise, dust, and air pollution. A balanced answer might say, the quarry should only be approved if strict conditions are met, such as limiting lorry routes, restoring the site afterwards, protecting the most valuable landforms, and investing some profits into conservation. However, we also need to remember the sustainability issue. Once rock is removed, it is gone. A destroyed drumlin field cannot simply be rebuilt. That means some impacts are permanent, even if the company promises restoration. To summarize today's lesson, glaciated landscapes are not wasted or empty spaces. They are multifunctional landscapes used for tourism, farming, forestry, quarrying, water supply, and energy production. Tourism brings jobs and income, but can cause congestion, footpath erosion, litter, and visual pressure. Quarrying provides materials and employment, but can damage scenery, habitats, and geological features. Farming and forestry support rural economies, but can affect soils, biodiversity, and ecosystems. Reservoirs and HEP provide water and renewable energy, but can flood valleys and change natural landscapes. The key challenge is balancing development with conservation. That is why sustainability is so important. The future of glaciated landscapes depends on whether people can use them without destroying the features that make them valuable.